Arsenic speciation and mobility in surface water at Lucky Shot Gold Mine, Alaska. The purpose of the study was to determine how abandoned mine sites, specifically Lucky Shot Gold Mine in the study, has affected the surrounding land and how they contaminate the groundwater quality through leaching of potentially toxic metals, including arsenic, and the quality of drinking water. There is a well-established connection between the adverse impact of arsenic on the environment and on human health. Arsenic contamination of drinking water is a serious public health concern in many regions of the world. Contamination can be attributed to both natural and anthropogenic sources, and there are currently many active mining claims near Lucky Shot and a renewed interest in reopening some of these mine sites because of the high price of gold. Arsenic is a naturally occurring element, and arsenic toxicity is a global health problem affecting many millions of people. Arsenic is a well-documented human carcinogen that affects numerous organs, and prolonged exposure can cause cancers including skin, lung, and may cause other internal cancers as well. Mining is one of the causes of arsenic contamination in ground and drinking water. The Lucky Shot mine site is typical of many abandoned gold mine sites in Alaska and has had little or no remediation after the closure of the site. Some of the questions of the study are: do the thousands of abandoned mine sites affect groundwater through leaching and contamination of toxic metals, including arsenic? And are the levels of arsenic contamination high enough to cause concern for the public? Baseline geochemical studies were undertaken to assess arsenic mobility in the surrounding area of the mine adits. Future underground mining at Lucky Shot may further adversely impact the water quality. Environmental monitoring was occurring when water samples were collected from streams, adits, and boreholes around the mine and analyzed for both major and minor elements. Stream sample points were selected to intersect likely areas of contamination from adit outflow. This slide has some pictures of a main access portal, and an adit to give you an idea of what the study is talking about. An adit is a horizontal passage leading into a mine for the purpose of access or drainage. Implications of human health and the main environmental concerns at these sites include presence of leaking fuel storage tanks, toxic metal leaching from tailing piles, acid mine drainage from the adit, and contamination of soil by mercury used to extract gold from the crushed ore. The study is an ecological study as it uses information on exposures and health outcomes ascertained at a community level, and it also uses surveillance biomonitoring as it tracks the health hazard of the release of toxic chemicals, which would be arsenic in this study. Shorty Creek is upstream of all mining activity and can be considered as a baseline for the study. Water samples taken from other creeks show the natural water quality is exceptional, with high clarity and no inorganic contaminants close to the EPA limits for drinking water. In all of the samples collected, metal concentrations are below the EPA maximum contamination levels for drinking water, with the single exception of arsenic. Levels of arsenic in surface water are above the EPA drinking water MCL requirements near Lucky Shot. The drainage of the main adits were found to be the main source of the arsenic contamination in the water, and below is a chart showing how much higher the Lucky Mine adit arsenic levels were compared to Shorty Creek and what the EPA levels are. The water in the system is primarily derived from rainfall and the spring melting of the snow in the valley. Water that is collected from the monitoring boreholes is more ambiguous, which suggests some mixing between rainfall and groundwater. The recharge rate in some of these wells is very slow and not likely to be typical of the aquifer. The main source of arsenic in the water course is from drainage of the mine adits. Total arsenic is rapidly diluted within several kilometers of the source, and it is concluded that the historical mine site is unlikely to pose a significant health threat to communities in the Willow Creek Valley. There were no suggestions from the authors in how the study could be improved with further testing or a different approach compared to this current study. The slide shows the citations that I used for this project. And some of the questions I'd like to pose are: is future hard rock mining worth the possible risks? And should a health impact assessment be in place in determining further future mining of such mines like Lucky Shot?